Hi there. This video is looking at standard form, specifically really small numbers. So you might want to check out the video on standard form with large numbers first. Okay, so let's get straight into examples. The mass of the average human cell is approximately 1 nanogram. This is equal to 1/1000th of a gram. So if we write this number in ordinary form, it would look like this. Okay, so 0.00000000001 gram. Let's write this number in standard form. Because this number is really small, we're going to end up with the power of 10 in standard form being a negative power. Let's have a look at why that would be. If I have 1 times 10 to the negative 1, what that means is that negative power is the same as 1 over 10 to the 1, okay, which is the same as 1/10th. So if I'm going 1 times 1/10th, it's the same as saying 1 divided by 10. So we're actually making the number smaller. If I have 1 times 10 to the negative 2, this is the same as saying 1 times 1 over 10 squared, which is the same as 1 times 1 over 100, which is equal to 1/100th. Okay, so we're making the number really small. So the way we do this is we look where the decimal point is in the ordinary form of the number, and if we were to start with 1.0 times 10 to the power of, we know it's going to be a negative power, what power of 10 do we need to multiply 1.0 by, to get back to this ordinary number? So if the decimal point was here in our standard form way of writing it, we would need to multiply by a negative power of 10 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 times 10 to the negative 9 is the same as this number here. So what is the weight of 35,000 of these types of cells, which have a mass of 1 times 10 to the negative 9? So our calculation we're doing is 35,000 times 1.0 times 10 to the negative 9. So let's grab our calculator. So 35,000 times, plugging this in, 1 exponent button, and then we're going to use the negative button here, so negative 9. And we get 3.5 times 10 to the negative 5. So if we go back to the calculator, with the exponent is negative 0.5, which is just negative 5. Okay, this next example here, the average human skin cell is approximately 30 micrometers in diameter. So how would we say that? 30 micrometers looks like this, and micro means 10 to the negative 6. So what we have is 30 times 10 to the negative 6. Let's just plug that into our calculator and see what we get. 30 exponent negative 6. That's the same as saying 3 times 10 to the negative 5. So how many skin cells could fit in 1 millimeter if they could be lined up next to each other. So we've got 1 millimeter, just recalling that this is meters here, so 30 micrometers is 3 times 10 to the negative 5 meters. 1 millimeter is how many meters, or what fraction of a meter is 1 millimeter. So there are 1,000 millimeters in 1 meter, so 1 millimeter is the same as 0.001 meters. So we've got that length, and we need to divide that by the diameter of a human skin cell. So divided by 3 times 10 to the negative 5. And that should give us the number of human skin cells that are in 1 millimeter. So 0.001 divided by 3 times 10 to the negative 5. So just make sure you use the negative button, not the minus button. 33 1/3. So about 33 skin cells. Okay, let's look at some atomic structure here. The mass of a neutron is 1.6725 by 10 to the negative 24 grams. The mass of an electron is that number there, and the mass of a proton is that number there. A carbon atom is made up of 6 neutrons, 6 protons and 6 electrons. What is the mass of 1 carbon atom? Okay, so the mass will be 6 times the weight of each of these types of subatomic particles. 6 times the mass of a neutron, so 1.6725 by 10 to the negative 24 plus 6 times the mass of an electron plus 6 times the mass of a proton. It should be 28 there. That is equal to 2.00892654 times 10 to the negative 23. So let's just round that to 2 times 10 to the negative 23 grams. Okay, this last example, we have the length of the shortest wavelength of visible light, violet, being 4 times 10 to the negative 7 meters. What is this length in millimeters? So we know that there are 1,000 millimeters in 1 meter. So in 4 by 10 to the negative 7 meters, we're going to have 1,000 times that length in millimeters. So 4 times 10 to the negative 7 times 1,000 will give us the number of millimeters. Okay, so 4 exponent -7 times 1,000 equals 4 times 10 to the -4 millimeters. Let's just write these two numbers in ordinary form. So this number here, if we have, it's going to be a very small number. So if I write 4 here, and then just a few zeros, in our standard form way of writing this number here, the decimal point is here. So we want to divide by 10 4 times. So times 10 to the -4 meaning that we're dividing by 10 to the -4. So each time we divide by 10, we take the decimal point to the left by 1 spot. So that's 1, 2, 3, 4. So 0.0004 millimeters. If we do this one here, okay, our decimal point is here, and so we're going to divide by 10 to the power of 7. So we're moving our decimal point to the left 7 spots. So let's just add a few zeros. So that's 1, 2, 3, 4, 5, 6, 7. So 4 times 10 to the -7 is the same as 0.000004. Thanks for watching.